Hi, today I'll be doing my Topic 2 presentation, talking about the different aspects in Unit 2. So first I'm going to talk about the architecture of the CPU and the functions of the arithmetic logic unit ALU and the control unit CU and the registers in the CPU. Obviously, the arithmetic logic unit, the CPU, does all the calculations for the CPU or the central processing unit for the computer. And the control unit basically makes sure that the computer is in sync and is in control. And there are different types of registers in the CPU that basically help store quick memory in the CPU, such as the memory destination register is one example. Obviously, there are more, but this is the one example I put, with the MDR being the one that holds the destination for memory that the CPU will use to then fetch data. Primary memory. Obviously, there's different types of primary memory. There's volatile and non-volatile. And then volatile basically refers to how the memory, if power is lost to it, then it will lose all of its data in it. And non-volatile basically refers to how if no power is there, the memory will still be in that storage. Cache memory. The use of cache memory specifically. Obviously, cache memory in itself is basically memory between the CPU and the RAM. That small little memory between CPU and RAM basically helps quicken. Cache is known as quick memory that is in the CPU that quickens and kind of helps store instructions and data in the CPU. Obviously, it is not big, but it's very, very fast. It goes into level 1, level 2, and level 3. Level 3 is the slowest, but the most memory, and level 1 is the fastest with the lowest memory. Now, this is the machine instruction cycle. In this cycle, we can see that there's three steps, but the fourth one that you can obviously tell is the three main ones are decode, which execute and fetch. First, fetch happens where data from the RAM is taken in the control unit of the CPU. Then decode is where the data is actually decoded, and then execute is where it is then taken in the ALU unit and executed. Need for persistent storage. Obviously, when you have a computer and you do not have persistent storage, such as your laptop, then you won't have BIOS. And in BIOS or Bootstrap is how your computer runs. And if you do not have that, then your computer will not be able to start in what is happening. Operating system main functions. Obviously, the operating system has many, many main functions, but the main one is to basically manage users and make sure that the system is running right and to be able to execute different functions that the computer runs or that the user runs. Range of application software. Obviously, there's major ranges of application software, such as word processing softwares, such as spreadsheet softwares, such as browser softwares. In the browser softwares, we have softwares that provide a GUI for users to access the internet and browse the internet. And also, for spreadsheet software, we have users that are able to enter data into columns and tables and be able to manipulate them using formulae. Features of applications. There are very many features of applications, such as, for example, I'll give one example here, is of the browser. In the browser, we have a URL hotbox, we have a search engine, and we have full screen minimizing and closing buttons on the top right, which help the user manage bit, byte, binary, denary, and hexadecimal. These are all different base terms, and denary is a 10 base number system from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hexadecimal, on the other hand, is a 16 base number system from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, which is 16 digits. Bits are a one binary digit with 0 or 1. Byte is 8. Byte is 8. And binary is a 2-base system with either 0 or 1 taking up each digit. And computers only use bits and binary as the transistors in a computer work on or off, which is what binary is. The way data is represented in computers many different ways. Obviously, data can be represented through GUIs and different software applications throughout the computer. And or not, NAND, nor XOR. These are all different truth table, truth tables and logic gates. An AND gate is basically a gate where if two inputs are inputted in and both are inputted in and both has two inputs and both are positive, then it'll give a positive answer. If it's OR, if even one of them is positive, then it'll give a positive answer. For NOT, it does the opposite. And for NAND, it basically checks if there's two inputs that are positive, and if it isn't, it'll still give a positive answer as it is an AND with a NOT, which reverses it. NOR is the same thing, where if it's either or, has an input, positive input, it will give a negative. As what happens is when NOR, it's an OR gate with a negative on it, or a NOT gate connected to it. XOR is different. It's exclusive OR, which basically means that the both inputs are added. And when binary is added, 1 plus 1 equals 0 with a remainder of 1, which is the answer you will get, and 0 plus 1 equals 1, which is simple. Truth tables. Obviously, these different logic gates can be split into truth tables, as I mentioned in an earlier slide, where we can see the inputs and the specific outputs we will get. And the way we determine how many inputs can get how many outputs is we do 2 to the power of how many inputs we have. So to get how many columns we can get. So if it's 2, then we do 2 to the power 2 to get them as many columns and tables as we need. Logic diagrams. Now, as mentioned in the earlier slide, before truth tables, we had different logic gates. Now, if we combine these logic gates, we can get different types of diagrams that can represent different problems and